Prime and composite numbers, let's talk prime factorization. Now, all prime numbers can be written as a unique product of primes, meaning we can take prime numbers, multiply them together, and we will get a composite number. So prime factorization helps us compare numbers because we can break down any composite number into this prime factorization. We can use that prime factorization to simplify fractions, to find different multiples and common factors between numbers, really for a lot of different things. So how do we do it? Well, to find the prime factorization, we are going to start with any factor pair of the given number. There's almost always more than one way to start. So just start with two branches with the factor pair. And then when you break that down, and we're going to do some examples, but if you break it down and one of those numbers is prime, then you circle it because that branch is complete. If when you break it down, you still have a composite number, then we're going to break it down again, and we're going to kind of create a tree looking. And the goal is to continue until all branches end with prime numbers. So we're going to have circles at the bottom of every branch because we always circle the prime numbers. All right, let's jump into this. We're going to find the prime factorization of 60. Now I'm going to do this one way and then I'm going to show you just have a diagram of a different way. But if I'm going to break down 60, I am kind of hardwired that when I see an even number, I always say, ooh, that's 2 times 30, because in my head, that's kind of an easy way to break it down. And 2 is prime, so I circle it. Now I can break 30 down into 2 more branches. So what multiplies to get 30? Well, when I see 30, I think 5 times 6. So 5 is prime, so I circle that. Now I look at 6, and 6 breaks down 2 and 3, both of which are prime. So now you can see at the bottom of every branch, they are circled. So I have 2 times 2 times 3 times 5. So that is the prime factorization of 60. Oftentimes, if we have repeated numbers, so 2 times 2 is the same as 2 squared. So I would take 2 squared times 3 times 5 equals 60. So that is one way to do like the factor tree for the prime factorization. You can see that another way to do it would be to start with 6 and 10. If you do 6 and 10, then 6 breaks down 2 and 3, 10 breaks down 2 and 5. You still get the same answer of 2 squared times 3 times 5. So it does not matter how you start. It's just important that the two factors multiply to get the number you're working with. Let's do another one. 48. So if I look at 48, this time I'll do it a little bit differently, but 48 jumps out 4 times 12. And again, it doesn't matter where you start. I then see that 4 breaks up 2 and 2, so I can do that one. 12, 2 and 6, and then 6 breaks down 2 and 3. So when I see this, I've got 2 times 2 times 2 times 2 times 3. So that means 2 to the 4th power times 3 equals 48. There's the prime factorization if you start with 4 times 12. But again, you have different options. So you could also 48 is 6 times 8. So if you start that way, then 6 breaks down 2 times 3, 8 breaks down 2 times 4, and then 2 times 2. You still get the same answer of 48 equals 2 to the 4th times 3. I love this stuff, right? There's multiple ways to get there. All right, you try this one, prime factorization of 120, and then come back and see how it works. All right, so let's work with 120. Lots of ways to start, but I am a creature of habit. So 2 and 60. I don't want to think too hard. So when I see a number that's even, I always just break it down. So then I would 2 times 30. And then I would have 2 times 15. Well, 15 gets my first odd number, but it's small enough that I know easily that it's 3 times 5. So when you look at what we have left, we've got 2, 2, 2. So that's 2 to the 3rd power. Then I've got a 3, and then I've got a 5. And that equals 120. So we're looking at 2 cubed times 3 times 5 equals 120. Again, if we want to think about, well, what if we do that a different way? Well, what if you started with 10 times 12? Because it ends in 0, think about your divisibility rules. If a number ends in 0, it's divisible by 10, and then you can break it down from there. Doesn't matter which way you start, as long as the numbers you're multiplying work, right? 10 times 12 is in fact 120. As long as that's true, you'll get the correct prime factorization in the end.